What is a tsunami? A tsunami isn't just a big wave caused by storms or winds. Unlike regular ocean waves that form because of air moving across the sea's surface, tsunamis are created when something pushes or pulls at the water from below. This push usually comes from earthquakes, but can also be triggered by volcanic eruptions or landslides. What makes tsunamis unique is their scale. They can stretch across entire oceans, traveling at speeds of over 500 miles per hour, 800 kilometers per hour. Out in the deep sea, a tsunami might be only a meter high and barely noticeable. But as it approaches shore, the energy behind it compresses, and the wave can grow into a towering wall of water capable of wiping out coastal cities. How do earthquakes work? Earthquakes happen when the massive slabs of rock known as tectonic plates grind, collide, or slip past each other. These plates make up the Earth's crust, and their edges are zones of constant tension. The most important for tsunamis are subduction zones, where one plate is forced beneath another. Over decades or even centuries, stress builds at these boundaries until the rock suddenly gives way, releasing energy equivalent to hundreds of nuclear bombs. If this happens under the ocean floor, the sudden jolt can lift or drop huge sections of seabed, and in turn, displace enormous amounts of water. This is the starting point of a tsunami. Step-by-step process of a tsunami's birth. First, the tectonic plates lock together over time, storing massive amounts of energy like a compressed spring. Second, when the stress overcomes the friction holding the plates, they snap suddenly, producing an earthquake. Third, if this earthquake takes place beneath the ocean, the seafloor itself shifts upward or downward in just seconds. Fourth, the water above the shifting crust is pushed aside, lifted, or dropped, which displaces millions of tons of seawater almost instantly. Fifth, that disturbed water tries to return to balance, and gravity forces it into waves that travel outward in every direction. Sixth, these waves race silently across the deep ocean, where their crests are so far apart that ships hardly notice them. Finally, as the waves reach shallow water near coastlines, they slow down, grow taller, and become the towering, destructive waves we recognize as tsunamis. The 2004 Indian Ocean Tsunami, one of the deadliest natural disasters in history, shows this process in action. On December 26, 2004, a magnitude 9.1 to 9.3 earthquake struck off the coast of Sumatra, Indonesia. The seafloor shifted dramatically along a fault line more than 1,000 miles long. This sudden uplift displaced billions of tons of water, creating a tsunami that sped across the Indian Ocean. Waves as high as 100 feet devastated coastlines in Indonesia, Thailand, Sri Lanka, and even distant Somalia. Entire towns were wiped off the map, and more than 230,000 people lost their lives. This event shocked the world and highlighted how an earthquake in one location can create destruction thousands of miles away. The 2011 Japan Tsunami. Another tragic example happened on March 11, 2011, when a magnitude 9.0 earthquake struck off Japan's Tohoku region. The seafloor lifted more than 30 feet in some areas, generating a massive tsunami. Waves over 40 meters high crashed onto Japan's coastline, sweeping away homes, cars, and entire communities. More than 18,000 people died, and the tsunami triggered the Fukushima nuclear disaster, creating long-term consequences for the environment and energy policy. This disaster showed how tsunamis can have cascading effects, destroying infrastructure, causing economic crises, and leaving scars for generations. The 1960 Chile tsunami, the largest earthquake ever recorded, a magnitude 9.5, struck Chile in May 1960. The quake caused a massive tsunami that didn't just impact South America, it traveled across the entire Pacific Ocean. Hawaii was hit within 15 hours, Japan was struck after 22 hours, and waves even reached New Zealand. Thousands of people died across multiple countries. This event proved that tsunamis are not just local disasters, but global ones, capable of moving across oceans and affecting countries thousands of miles from the epicenter. Why every earthquake doesn't trigger a tsunami? Not every earthquake produces a tsunami, and the reasons are clear. First, the earthquake must happen under or near the ocean. Inland earthquakes, no matter how strong, won't displace seawater. Second, the quake must be large, typically magnitude 7.0 or higher, because smaller quakes don't move enough sea floor. Third, the seafloor movement must be vertical, lifting or dropping sections of crust. If the quake only shifts side to side, as in strike-slip faults, very little water is displaced. Finally, the earthquake must be shallow, usually less than 70 kilometers deep, because deeper quakes lose too much energy before reaching the surface. These conditions explain why thousands of quakes happen every year, but only a few result in tsunamis. The physics of tsunami energy. Tsunamis are powerful because of their wavelength. A normal ocean wave might have a wavelength of 100 meters, while a tsunami's wavelength can stretch up to 200 kilometers. This means the energy is spread out over a massive area. In the deep ocean, the waves might seem harmless, only a meter tall, but their incredible length allows them to carry enormous energy across entire oceans. By the time that energy is forced upward near the shore, the waves become destructive walls of water that can flatten buildings and drag debris miles inland. Warning systems and natural signs. One of the biggest challenges with tsunamis is early warning. Modern systems use a combination of seismic sensors to detect large undersea earthquakes and DART buoys to measure pressure changes on the ocean floor. Data is sent to tsunami warning centers, such as the Pacific Tsunami Warning Center in Hawaii, which issue alerts worldwide. Still, technology has limits, and sometimes the only warning is nature itself. If the sea suddenly pulls back from the shore, exposing the seabed, it's often a sign a tsunami is moments away. Tragically, during the 2004 Indian Ocean tsunami, many people walked out to the exposed seabed without realizing they had only minutes to escape. Human preparedness and lessons. Learned countries at risk of tsunamis have invested heavily in defenses. Japan, for instance, has seawalls, evacuation routes, and regular drills. But even the best defenses can be overwhelmed, as seen in 2011. Education is often the best weapon. In some Indonesian villages during the 2004 tsunami, children and adults survived simply because older generations had passed down oral traditions warning them to run to higher ground when the sea suddenly disappeared. These stories show that technology and tradition together are vital in preparing for the next big wave. So, why do earthquakes trigger tsunamis? Because when the Earth's crust shifts beneath the ocean, it displaces enormous amounts of water, setting off waves that can travel entire oceans and destroy coastlines in hours. We've seen how this process unfolded in Sumatra, Japan, and Chile, and we've learned that while not every earthquake causes a tsunami, the ones that do can change history in a single day. By improving detection systems, sharing knowledge, and preparing communities, we can reduce the risks and save lives. Next time you hear about an undersea earthquake, you'll know exactly why scientists immediately issue tsunami warnings. It's because the shaking ground and the moving ocean are deeply connected. Thanks for watching. If you found this explanation helpful, make sure to like, share, and subscribe for more deep dives into the science that shapes our world. Stay safe, and I'll see you in the next video.